Okay, so 2.4, I believe this is the last section in the chapter before we head on to chapter 3. So you probably should be expecting a quiz coming up soon and, of course, a test in the next week or so. So we'll give you more details as that comes along. But this is the last section. This is the cosine law. Now, we took a look at the sine law in the last section. This section is the cosine law. So we're dealing with trig functions again. We're also dealing with non-right triangles again. And this law helps us to solve different types of problems than the sine law would. And so just as so this is what 2.4 looks like here. I'm going to skip the first little part. I mean, you can work through this if you want on your own, but I'm not going to go through the investigate. I do want to just talk a little bit about the cosine law and what it is. We'll work through it. The proof of the cosine law, I'm not going to spend a whole lot of time on the proof of the cosine law either in this shortened lesson, but what I want to just explain to you is some things that might be helpful to give you just a big picture. Okay, so again, I'm not going to be doing the proof. This is what it looks like in the textbook. We are dealing with an altitude again, just like we did in developing the sine law. So we're dealing with a non-right triangle and an altitude here. It's just set up a little bit differently, okay, as you can kind of see. But what is loosely connected here is the Pythagorean Theorem. So you notice that we are talking about the Pythagorean Theorem, and that's really important. So I've got this in my notes, so I'm going to flip over to here. This is the setup for the cosine law, okay? So the first question I have for you in introducing the cosine law is this. Is it possible to determine the length of side A using the sine law? So in this triangle right here, we have one angle and we have the side lengths that form that angle. So we do not have any other angles in the triangle, and we don't have the opposite side. So the sine law, we're looking for what? To use the sine law, what are we looking for? A what? I've mentioned this several times. In order to use the sine law, we need a what? Angle and opposite side pair, right? So we need to have an angle and an opposite side pair, at least one of them. We don't have an angle for this side. We don't have an angle for this side. We don't have a side for this angle. There's no way we can find out the other angles using the 180 minus, angle. Can't do that. And so we can't use the sine law. We're kind of stuck. When you have a situation like this where you have side, angle, side in a triangle, SAS, this is when you're going to have to use the cosine law. Okay? So the cosine law, and again, this is the cosine law here. I'll clip this out so we can make some notes on it. Yeah. And the cosine law, as I mentioned before, is for non-right triangles, so you can still use this trig function cosine on non-right triangles. And here's the cosine law in general. If you want to write this down, c squared, so this would be the side that is opposite of the given angle. So we do need to have one angle. The side that's opposite the angle there, that's the one you want to put over here. Now, I guess we don't need an angle to use the cosine law, but if you have an angle, you can start with finding the opposite side to that angle using the cosine law. And I think what's interesting about this, and this is what jumps out to me, is that this is virtually the Pythagorean theorem. You see how c squared equals a squared plus b squared? That's the Pythagorean theorem right there, isn't it? Okay? And so this is how I look at it. And this is not a proof. This is maybe not the best mathematical way to explain this to you, but this is how I look at it. And this is how it makes sense to me. How I remember the cosine law is that it's Pythagorean, it's the Pythagorean theorem. Okay? And let me just draw something here that might kind of help. So if I have a triangle that looks like this, and let's pretend that that's a right triangle, okay, and I have C, and I have A, and I have B, then the Pythagorean theorem says that a squared plus b squared equals c squared. You got that? Okay? Or c squared equals a squared plus b squared. That's the way it's written up here in this part. All right. So this part over here, okay, what's up with this part? Now, notice something, that the angle C is actually right here. What is the cosine of 90? What's the cosine of 90? Well, you may remember that it's a quadrantal angle. The cosine of 90 here is 0. You checked that on your calculator too. It should say 0. So guess what? If this is a 90-degree angle, we have the Pythagorean theorem minus 0. It's just the Pythagorean theorem. So it's almost like this isn't even here. Now that's neat, but if this was not a right triangle, okay, and let's say that I'm going to just change this a little bit. So let's say it's not a right triangle. Then you can kind of see that if I'm trying to find out what this angle C is, and maybe what this side C is, that it's really super close to be in the Pythagorean theorem. But because this is not exactly 90, I'm not subtracting exactly 0, am I? The cosine of C is actually a value that's not 0 now. And so, to me, this is easier to remember if I start with the Pythagorean theorem, and then I say to myself, because this is not a straight 90-degree angle, I have to account for this. That A is going to be a bit longer. B is going to be a bit longer. Okay, so I have to have something extra, and that's what makes up the rest of the cosine law. So that's not a proof. That's just me talking in layman's terms, trying to help you kind of see the big picture of the cosine law. It's really just the Pythagorean theorem, and we have to have this little extra on here to account for the fact that this is not a 90-degree angle. Okay, so now let's do this again. So if you have c squared, you're going to let that equal a squared plus b squared. That's the way you start, Pythagorean theorem. Now you subtract 2 times whatever these side lengths are, 2ab. And then you multiply it by the cosine of the angle associated with this side, c. Now that works for any side and any angle. So that's why they have the other sort of iterations of this law. Because if you want to do this way, watch this. If I want to find a, or if I'm given a, then it's like this. So a squared equals b squared plus c squared. So you always have the other two sides. Minus 2 what? bc times cos of what? A. So it's the same pattern, and you can write it many different ways. So let's say I wanted to, I'm using the cos of b and this side b. Well, it's b squared equals a squared plus c squared minus 2ac times cos of b. So those are the different ways that you can use the cosine law in your work. Okay? But what you have to remember is that whatever this letter is, it's the angle that's the same letter on the end. Okay? Okay. So let's do an example here. Determine the distance. Determine an angle. What do we want to do? Okay, it's a little bit easier to determine the distance. So let's determine the angle. So let's do example 2. Okay? Example 2. Yeah, again, this is in your text. You can follow along in your text as well, but if you don't have that with you, you can just watch this. So, determine an angle. The Lionsgate Bridge has been a Vancouver landmark since it opened in 1938. It is the longest suspension bridge in Western Canada. The bridge is strengthened by triangular braces. Suppose one brace has a side length of 14 meters. So I'm just going to draw this 14 meters. 19 meters, okay, lengths of 19 meters. Okay, so here's going to be 19 over here. 19 meters. And then 12.2 meters. So however you draw that triangle doesn't really matter. Determine the measure of the angle opposite the 14-meter side. So that's going to be this one right here. Okay? So the strength of the cosine law is that you don't have to be given any angles. SAS, you can use cosine, but you can also, if it's an SSS triangle, that is side, side, side. If it's a side, side, side triangle, you can also use the cosine law. So in this case, we can solve for any one of the angles. Now notice that the cosine law, and whichever, doesn't matter which iteration you want to use here, but I'm just going to write this one down. Okay. So in this case, I want to find the angle that's in the cosine law. So let's say this is A. See that? This is going to be little a because we want to find the angle opposite the 14. So you just set it up like this. You go 14 squared equals, now which one's B and C? Doesn't matter. Doesn't matter at all. 19 squared plus 12.2 squared minus 2 times 19 times 12.2 times cos of, and A is unknown. Okay? So the math with this goes like this. You want to subtract 19 squared. You want to subtract 12.2 squared. That gets rid of these to the other side. So I'm going to write it all out here so you can kind of see where it goes. And then I'm left with this. And then what you do is you divide, because these are all multiplied together, you divide by -2 times this 19 and so on. And then we're going to be left with cos of A. All right? So this is going to be divided by there. Okay, so this is all gone now. And we're left with cos of A. So we're going to figure this out. Let's get the calculator going here and turn it on. So 14 squared minus 19 squared minus 12.2 squared divided by, now if you're going to do this all in one shot here, you might want to use brackets. -2 times 19 times 12.2. Closed brackets there. Actually, I probably should add some brackets to the top as well. Ah, that's no good. Insert. Okay, this is divided by. So yeah, so if you're doing this, I would add brackets so you get the whole top divided by the whole bottom there, and it looks like I'm still missing something there. Let's delete that. Is that good? All right. So we have looks like we have 0.67696. All right. And so then what we do, how do we get A all by itself here again? Guys remember? Cos to the -1, right, of both sides. Okay. So let's do that and see what we get. Cos, second function cos of our answer. Just put the whole answer in there. We get 47.393. So that gives us the angle, 47.4 whatever. That's the angle A that we're missing here. Oh, to the nearest degree, so 47. I just see that now. Okay, and that should be the answer that you get there. Any questions about that? Okay, you would do well to memorize the cosine law here in one form, and then be able to just plug in values as you need to. Okay, so that's the intro to the cosine law. I'll just show the summary page for you. Let you take the key ideas. Let you take a look at that for a moment.